folk, I don't mean to be teaching theology, but this is, to me, it's science. And if you have millions of years, that won't really help you. The idea that your living cell can come together and function, even given zillions of years, is almost impossible beyond belief. Scientists have estimated it. There are 10 to the 90 atoms in the universe. The odds of a living cell coming together have been estimated at 10 to the power of 245, and some estimates are even higher. Even given millions of years. You have to get every atom in the right place, and folk, as soon as they're together, the processes must start. All right. Anybody else? Anybody at all have any comments? Okay. Again, hopefully I've gotten you thinking. This is what I wanted to do. In 1871, Darwin published Descent of Man, which he said that humans originated from animals. Again, each of you can make up your mind for yourself. You pretty well know what I think. Realism. This was about the time the photograph was invented, but the earlier photographs did not really show true realism, so artists still strove for realism. Your book shows an example of this type of painting, romantic. This is the romantic period, as you'll learn if you listen to the videos. And realism was a big part of the romantic art. Charles Dickens, a famous author who wrote, among other things, about Ebenezer Scrooge. Have any of you, by any chance, seen it or read about Scrooge, Ebenezer Scrooge, and his friend Marley, who came back as a ghost and warned Ebenezer Scrooge of the evil of his ways at Christmas time? Oh, yeah. Charles Dickens fought poverty, opposed poverty, and encouraged people to help the poor. That is somewhat amazing because evolutionists said they fury on the poor, let them rot because the poor are inferior, and the idea is to enhance the strong. Your book goes on to talk about other artists, novelists, but the only two I've mentioned. Well, romantic art and Charles Dickens. All right, a new physics. The physics of Newton is sometimes referred to as classical physics, where the space, time, and matter were objective realities that had their own properties. Matter was thought to be composed of indivisible and solid material called bodies of atoms. Today we know the atom is far, we think, all right, I'm going to say this is the theory, you can't actually see an atom, but we suspect the atom is far, far from being solid, that it's 99.99% empty space. Again, are you taught this in your chemistry classes? That the wall that seems solid to us is actually 99.9% empty space? Yeah, because what makes it seem solid is the motion of the electrons. The electron is moving so fast around, it seems to be everywhere at once. And this gives the atom its seemingly solid feel to it. What's that? Magnetism. About this time, too, a French scientist, a female scientist named Marie Curie, and her husband Pierre Curie, they discovered an element called radium. And this radium gives off radiation that convinced the world that atoms were not just hard, solid bodies, but that they had something, that they were made up of particles, smaller and smaller particles. This was to lead to the development of quantum physics, or the study of the particles that make up atoms, or subatomic particles. and lead us to discover the proton, neutron, electron, and even the protons and neutrons are made up of little particles called quanta. Madame Curie did not know any better. Hopefully all of you do. So she handled radium and uranium for a long time and wound up dying of leukemia. Again, this is what radium will do to a person who gets exposed to too much of it. It will give you a case of leukemia. And she died younger, but she was honored as one of the more outstanding female scientists of all time. The Curies believed that the radiation occurred at irregular intervals, but Max Planck came along and he said that no, these are very regular, and he is credited with inventing the quantum theory. And the quantum theory. Now, again, folks, I want to say about quantum theory. It is somewhat possible that everything we believe about, well, quantum may prove to be thoroughly incorrect. It's theory, like a lot of others. But nevertheless, I mean, I don't have a real quarrel with it, but I have heard persons say that there are alternate other explanations than the ones that Max Planck came up with. Which takes us up to Albert Einstein. Somehow the younger generation is not as enthused about Einstein as we were. But Einstein's name is now associated with the name of genius. In fact, he was so intelligent that at his death he gave permission for them to take out his brain and study it. His brain has been well preserved, and we have just within the last year discovered that he had more frontal neurons, or more connections between one part of his brain and another, than most people do, which might indicate why he was so smart, at least in the area of mathematics. Having said he was really smart, I've got to tell you a few stories. I mean, there's stories told about him being kicked out of his classroom for outsmarting his professors. But there are other stories. He was roaming around his neighborhood one day and finally grabbed me and said, "Will you please help me? I can't find my house. My name is Albert Einstein. Can you please tell me where I live?" And well, basically what I'm saying is sometimes these men who are extremely smart in one area of their life are extremely lacking in intelligence in other areas. Anyway, he's famous for his theory of relativity, a theory that all motion in the universe is relative, that space and time are not absolute, but they're dependent on the observer. So, in other words, if you are going along at a speed near the speed of light, a strange thing would happen. Time would either speed up or slow down. Now, here's what he didn't know. Supposing someone went off in a spaceship at 175,000 miles an hour and left another person behind, and they eventually got together, which one would age the most? Would the one who was going 175,000 miles an hour while the other person stood still, would he do the aging? Or would the one who was standing still do the aging while the other one did not age?
Standing still would age.
You think so? I mean, the point I'm trying to make is Einstein didn't know. And when I read about relativity, the author said, "I'm going to leave you to figure it out for yourself." And you can think, because standing still is a relative term. The one who takes off in a rocket and goes 100,000 miles, the one who's standing still is actually moving away from him at a speed of 175,000 miles a second. So which one is moving, which one's standing still? Relatively speaking, one of them is moving, the other was standing still. But we don't know which one's moving, which one's standing still. We really don't. And therefore, we don't know which one would age and which one would not. He's also famous for another one of his formulas. The formula E equals mc squared, energy equals mass times the speed of light squared. And for the first time he put matter and energy in the same equation, and of course speed of light, which meant that you could take matter and get energy from it. Before that, they thought matter and energy were separate entities. but he unified matter and energy. Well, basically, before his time, they had unified magnetism and electricity. Well, that meant that if magnetism, electricity, and matter could be unified, could we not unify everything in the universe into one big theory? He called it the unified field theory. Today we call it the theory of everything. Can we ever come up with one theory that's going to completely, the TOE, theory, that's going to completely explain the universe? Einstein spent the rest of his life working on a unified theory that would unify all fields. He never found one. Today's physicists have not found one either. But now this theory is credited with leading up to the invention of the atomic bomb, where they were able to split the uranium atom. When they did, it gave off a tremendous amount of energy. And the atom has been used to, from that day to this, to supply some of our energy needs. Sometimes these nuclear facilities have gotten us into a little bit of trouble. Particularly, the worst case was Chernobyl. And in Japan, not too long ago, the Japanese had a major earthquake that poured, a tidal wave poured water onto some of their nuclear plants. And this has created problems for them. We are going to have to learn to put our nuclear plants higher up above tidal wave possibilities. And also, in the United States, we make a nuclear plant in a building like this, which guarantees that if the thing falls, the building's going to fall on a nuclear reactor. There's only one way it can fall, folks, and that's down on itself. The Russians at Chernobyl did not do this, and the result is Chernobyl is now an uninhabited city where the Arctic facts in it can't be taken out. You can go to Chernobyl and for a little bit ride a bicycle there, and you'll see rusting automobiles with flat tires are flattened out by now. Pictures hanging on the wall that nobody dares, that are wrinkling and folding up, nobody dares take away because they're radioactive. Clothes, well, by now the clothing is pretty well tattered but left on the line, and the people were told, get out of the city, get out, don't, just go. They got out in a hurry without taking anything with them except what they wore, and then they had to get rid of that. And a lot of them died of cancers. Anyway, Einstein's theory, as your book says, led to the atomic age. Oh yes, Einstein also said that time and space are part of space and time are objects, not just abstract concepts, but space-time. We live in the space-time continuum, and what lies outside of that? Well, atoms won't hold together. There would be no laws of physics. The existence as we know it cannot exist. So our universe is finite and bounded by the extent of the space-time continuum inside which we live, in which everything we observe exists. So space is an object, a thing, you might say, tied in with matter. Is that too deep for many of you, or do you understand what I'm trying to say? Oh, yeah, some of you not yet, it's too deep. Well, whatever. Don't worry about that. But hey, folks, you might can tell, I find this stuff, this kind of reasoning fascinating. Sigmund